Hello everyone. As many of you already know, the inspiration for many of my blog posts comes from questions from users just like you. So today's post is no different. I recently received a question from a customer asking what was an easy way to create a subassembly that could look through multiple targets along a slope of the same surface and find the last intersecting point. So in an example similar to what you see on the screen on the left side, this could represent a earthen channel, a riverbed. In this case, it's actually a mine, like a limestone mine. But the result would be basically, I would like to follow a slope. You can see I have an example here where I'm just doing a simple generic link to slope to surface. But I would like to find on that slope path the last intersection point. So in this particular slope, you could see it would probably be right in here if I could do that. And of course, the slope to surface standard generic link is not going to work. So let's see how we could do this easily with Subassembly Composer. So I'm just going to go ahead and delete that slope to surface generic link. I actually do have a flat link that I'm starting with, and notice my corridor is set to rebuild automatic. So let's jump over to Subassembly Composer. I'm in an empty brand new subassembly here. I'm going to change my name to last intersection. I'm going to go to input parameters. I'm going to leave side. I'm going to create a new parameter. And this is going to be for my slope input, so I can control that in the input parameters. So I'm going to change that to grade. And default, I'll just leave as 0. Notice how that blanks out. I'll need to change that back to slope since I changed the type. Okay, so we're ready to get started. Last thing before I get into the geometry, before I forget, is the target parameters. I need to create a target setting. In other words, what is it going to be looking for, which is a surface target. I'll just call it EG here. It's a surface target, and now I'm good to go. So I'm going to start with a point just as always. If you look back at many of my previous videos, this is very standard. I'll just start with a point at the origin or the starting point. I'm going to go ahead and move my EG up. You'll see why in just a bit. See how I just grabbed the EG line near the name, moved it up. And I'm going to create now an auxiliary point. And I'm going to turn off the create link to auxiliary point because I don't need a link, an auxiliary link. And what I'm going to do is I'm going to go slope, and I could do delta X or Y, it doesn't matter. I'm just going to do delta X so I can put a large number in. I'm going to go from P1, and for my slope, I'm going to use the input parameter slope so that I can key this in. So there's my slope value that I'm going to enter. And for my delta X, I'm going to put 1,000 in. You could put 10,000, something very large, so that this would move far past any intercepting point that you're looking for. So I'm going to fit the screen here. And what I'll also do is change my default value on my input parameter for the slope to 60%, because that's actually the first slope I'm going to be using. And I'm going to move my EG up a bit. So you can see I just go out 1,000 feet or 10,000 or whatever along a slope that I key in and place an auxiliary point, which is just a point in memory, but not a real point. So now I'm going to come back with a real point. That'll be P2. And we're going to do the same thing. We're going to do slope, but we're going to do slope to surface this time because we want to find the surface. But this time we're going to work backwards. So from AP1, we want to go on our slope of minus slope, whatever our name is. And I want to reverse the slope direction. And I want to slope to surface. And my surface target is EG. You can see as soon as I select EG, that point goes along that negative slope path, and I have to reverse the direction or it'll think I'm moving away from center line. The reverse slope makes it go back towards center line and places a real point P2 at that location. So again, from P1 we go AP1 up at the slope value that I key in, or I'll be able to key in, 1,000 feet in this direction or 10,000, whatever you like. Then from there we move backwards, no link here either, minus the slope value that I key in, reverse the direction, so I'm moving back towards the center line, and we place our point at the final intersecting point of the existing ground. And the last thing we need is just to create a link, and that'll be between 0.1 and 0.2. And we'll test it here with the EG, pull that around, that looks good. Now remember, typically I would go into these parameters and create codes and other link shape point codes that would save me some time later, but here I'm just trying to show theory. So I'm going to select Save As and just call this last INT and close. So now in Civil 3D I just need to bring it onto the palette. So I go to my tool palettes and I already have a custom empty palette here. I'm just going to right click on the tab, select Import Subassemblies. We called it last INT. It's going to go on to custom. On a right click, refresh image. Then I'm going to select it, check my properties, see how the default slope is 60%. And now I'm just going to place it here. And I'm going to right click enter and then hit escape. And then the last step we need to do, I'll go ahead and zoom in on this particular section so we can see it happen. We need to set our targets. So I'm going to go to the properties of the corridor, set all targets for my mine surface or your riverbed, your channel. And you can see that it went past and found the last intersection along that 60% slope at this section. Well, let's vary those slopes and see how this behaves, make sure it works. I'm going to select the subassembly over here along the assembly. We'll go down to the slope value and let's try 50%. Okay, so you can see we moved to here. So that looks like 3 intersections we moved through. Let's change that to 40. So now we're all the way up to here along that slope. That's the last point at which it could hit. We'll do 35. I'll zoom out a bit. And you can see 35 because this is the top of the slope up here. You can see 35% pretty much took us to the very top of our mine slope. So we're shoring back. So now I could do volume checks to see exactly how much material would be removed or required to shore at this slope. Again, very nice for channel design, some type of river restoration, that kind of thing. So the goal today was to show a tip on using Subassembly Composer for finding the last intersection with a particular surface target. I hope this has been beneficial. Have a great day.